Okay, today we're going to start trigonometry, and trigonometry is trigonometry. We're going to talk about the tangent ratio, and the idea trigonometry is now we're going to bring together. So we studied Pythagoras' theorem, and we studied the angles. And we kind of started to make a connection between angles and sides. So that's the idea of trigonometry. It's this relationship, it's the study of math, it's a branch of mathematics that connects sides and angles. And so the idea is, you might have studied this in the past. We're going to be using three ratios. So we're going to be looking at right triangles in this class, and then we're actually going to move on to other types of triangles. But the three ratios, we're going to look at something called the sine ratio, the cosine ratio, and the tangent ratio. These are ratios. Okay, and so let me officially get rid of this pen. Whoops. So the idea is you're going to be given a right triangle. You're going to be given a right triangle. And you're going to be asked, and so let's take a look at this right triangle. It's a right angle here, right? We're going to call the two angles theta and beta, okay? And you're going to be asked to stand at one of those angles. Okay, and let's stand at theta. Stand at theta. And I'm going to say what side is the opposite. So we're going to use that word opposite. I'm going to say what side is the adjacent. And then I'm going to say what side is the hypotenuse. Once you have that information, we're going to put this information together, and we're going to be able to solve certain problems, connecting angles and the sides. The first ratio we're going to be looking at is tangent. So the tangent of theta, once again, you're standing at theta, and we say the tangent of theta is the ratio of the opposite side over the adjacent side. Now this is opposite, and this is adjacent. Opposite theta and adjacent to theta. Let's take a look at a video. Let's see. Okay, so this is a little thing I like to do with the kids each year. The idea is you have a right triangle here, and so you can see the right angle is right there, and I call the two angles alpha and beta. And I'm going to be asking you to stand at an angle and identify the side which is adjacent to it, opposite to it, or the hypotenuse. Now, this year, I'm never going to be asking you to stand at the right angle. I'm only going to be asking you to stand at the two acute angles, right? Because if their sum is 90, then each of them is acute. But so I'm going to say, hey, Avisha, stand at beta. So Avisha will stand here, and I'm going to say, Avisha, what side is opposite to beta? And she'll say, that side is opposite. And then I'll say, Arshan, please stand at beta. What side is adjacent? And Arshan will say, this side is adjacent. And then I'll say, Nicholas, what side is the hypotenuse? And he will say, this is the hypotenuse. Next, I'm going to ask Purva to stand at alpha. So she'll stand here at alpha. I will say, let's see, Kashamia, what side is opposite to alpha? And she'll say, that is now the opposite side, right? And then I'll say, Kennedy, what side is adjacent to alpha? He will say, this side is adjacent, right? Lastly, I'll say to Ryota, what side is the hypotenuse? And I'll say it's the same side as always. So once again, depending on where you're standing, opposite, adjacent. But if I'm standing at alpha, now that side is opposite and this side is adjacent. In both cases, this is always the hypotenuse. Good. Okay, we're back. So the idea is, so let's take a look at an example. So I have a triangle, a right triangle, and it's theta and beta, and we're going to use a triangle with a Pythagorean triplet, 3, 4, and 5. So simply put, if I ask you, what is the tangent of theta? You say, okay, Mr. Adler, I'm standing at theta, opposite theta is 4, and adjacent to theta is 3. Now, is that the only question I can ask you? You would say no. You could also ask us, what is the tangent of beta? Well, if I'm standing over here, what's opposite beta? You say now opposite is 3. And adjacent or next to is 4. Once again, from the video, the hypotenuse is never opposite or adjacent, always the hypotenuse, right? Good. Next. Now we saw from special angles that, we saw from the special angles unit that if we have like a 45, 90 triangle, we saw that the sides are 1, 1, radical 2. So I could say to you, what is the tangent of 45? And you say, oh, Mr. Adler, it doesn't matter where we stand, right? If I stand back here, opposite is 1, adjacent is 1. And so the tangent of 45 is 1. And you can find the others for 30, 60, 90. We'll get to that in a second. Next, the thing about tangent is that it's really another introduction to irrational numbers. So this is very calculator based. In this class, you'll always be using the GDC. So I'm going to use the GDC to find out what is the tangent of 11. I want to know what the tangent of 50 is. I want to know what the tangent of 72 is. And I want to know what the tangent of 83 is. I'm going to put the answers in a second. Pause the video. The answers will show up. Nice. Please make sure in your calculator that the settings are at, on the top of your calculator, you should see something called degrees. Nice. Now, last part. The last part. Let's see. Nice. Last 2 parts. So you're going to be given an example. You're going to be given an example, something like this. You're going to get a triangle, and I'm going to tell you that at the base, here it's 23 degrees, the opposite is x, and the base is 9. And the question is, how do I solve for x? Step 1. So what's step 1? Stand at the angle. Step 2, identify the missing and given sides as opposite, adjacent, or hypotenuse. So identify the missing or given sides as opposite, adjacent, or hypotenuse. 3, step 3, create a ratio and solve. Okay, let's take a look at this diagram. I'm standing at 23. I don't know the opposite, but I do know the adjacent. Oh, opposite over adjacent, That's the tangent ratio. The tangent of 23 is equal to x over 9. Well, first of all, this you can use NSolver to solve this. If you want to do it by hand, once again, the tangent of 23, you're always going to be using a calculator. So how do I undo division? Multiplication. Final answer, x equals 9 tangent 23. This is the exact answer. I'll write the approximate. You can figure that out. Try these on your own. Let's see. Let's get some ratios here. Let's try some more examples. How about this? Here's 51, x7. Take a look at this one. Pause the video. Okay, we're back. What do you think? Well, step 1, stand at the given angle. Step 2, identify the missing and given sides. Well, this is opposite, adjacent. The tangent of 51 is x over 7. X equals 7 tangent 51. Put this in the graphing calculator, see what answer you get. Here's a little more. Let's look at another problem. Let's see, 28, 11, x. Okay, what's going on here? Well, I'm going to pause the video. Let's come back. Okay, we're sitting at 28 degrees. I have the opposite. I don't have the adjacent. That's fine. I can still set up the ratio. The tangent of 28 is equal to 11 over x. It's a little tricky here. If you have to do it by hand, first thing I would do is multiply both sides by x. Right? And then the next thing I have to do is, how do I get rid of, remember a tangent of 28, we saw over here, these are just numbers. So how do I undo multiplication? Division. And so x equals 11 over the tangent of 28. Should we do one more together? I think so. Let's see. So let's try another one. How are we doing for time? I think we're in good shape, right? Yeah, we're good. Let's try another one. Let's see. Here's 80. And let's see, x and 15. Okay. Why don't you try setting this up on your own? Okay, we're back. I'm setting at 80. I don't know the adjacent, but I do know the opposite. That's fine. Opposite over adjacent, tangent. The tangent of 80 is equal to 15 over x. That's the tricky one. Either use NSolve, or you can practice this. But once again, the second you have a number like 80, if it's not 45, 30, and 60, you have to use a calculator. That's basically it. So you will always have a calculator. So you know what? Well, I remember x tan 80 equals 15, and x equals 15 over tangent of 80. Now, some of you might say, Mr. Adler, what if the angle is missing and we have the sides? Excellent. We have to do the reverse. It's known as the inverse. Right? So let's say I have a triangle here. And I don't know the angle, but I do know 9 and let's say, 12. Same thing. Stand at the angle. Identify the missing and unknown sides. Well, you know what? I know I have my opposite, I have my adjacent. Can I set up a relationship? And you say, yeah, if you have opposite and adjacent, that's tangent. the tangent of theta is equal to 9 over 12. Well, how do I undo tangent? Inverse tangent. Theta is equal to tan to the negative 1, 9 over 12. How do we get tangent of negative 1? What I want you to do, let's see, I'll probably talk about it in class, but what I want you to do, when you hit the map, when you hit let's see, hold on one second, we got a calculator. Where is my calculator? Yes. When you hit the trig button, when you press the trig button, you're going to see tan negative 1. Hit tan negative 1, put the ratio in there, and you'll get your angle answer. Once again, please remember that in the upper right-hand corner, your calculator should say DEG for degrees. And then, yeah, let's try one more. 9, 12, let's see. 6 and 11, theta. Let's call this beta. We don't have to use theta. We can use beta or any of the Greek symbols. Sometimes they use x. It's an unknown is an unknown. What do you think? Okay, well, which one is the opposite and which one is the adjacent? Well, 11 is the opposite, 6 is the adjacent. The tangent of beta, is 11 over 6. Therefore, B is inverse tangent of 11 over 6. Good.